Why did the logic gate go to the therapy? It had a lot of binary issues. What did the AND gate say to the OR gate? You're always so inclusive. Why did the digital
So
signal go to
today
the
we'll
doctor?
start with a
It
new
had a
topic
bit of a
called
problem.
digital logic
What do
and
you call a
systems.
logic circuit that's always making mistakes? A buggy design. Why did the flip flop go to the party? Because it was a binary bash. What did the counter say when it reached 10? I'm taking all the boxes. Why did the multiplexer go to the switchboard operator? It wanted to connect the dots.
Digital logic is the language of computers. Everything is built from zeros and ones.
Why did the flip flop go to the party? Because it was a binary bash. What did the counter say when it reached 10? I'm taking all the boxes. What do you call a digital system that's always efficient? A streamlined process. Why did the encoder go to the decoder? To get a translation. What did the logic analyzer say when it solved a problem? I've got the signal. Why did the digital circuit go to the gym? To pump up its processing power. What do you call a logic gate that's always creative? A gate with a twist. Why did the sequential circuit go to the doctor? It had a timing issue. What did the decoder say when it cracked the code? I've got the key. Why did the digital system go to the beauty parlor? It wanted a logical makeover. What do you call a logic circuit that's always reliable? A rock solid design. Why did the encoder go to the library? To look up some codes. What did the multiplexer say when it was feeling overwhelmed? I'm switching to a new channel.
So firstly we have the AND gate, then we have OR, then we have NOR, then we have the NOT gate, then we have the NAND gate, and then we have XOR. So these are the 6 different types of gates. Uh, so
What do you call a digital system that's always innovative? A cutting edge design. Why did the logic gate go to the art studio? To create some digital masterpieces. What did the counter say when it reached 100? I've got a century to celebrate. Why did the digital signal go to the music festival? To experience the beats.
so
What do
if
you
we look
call a
at
logic
the truth
circuit
tables
that's always
for each one,
precise?
so let's say for AND we have the truth table as so we have A, we have B, and we have Y. So we have a 0, 0 here. This translates to 0. We have 0, 1, 0. We have 1, 0, 0, and 1, 1, 1. So this is for AND. Then we can do it similarly for OR. So for OR, we have A, B, and Y. So we have 0, 0, 0. We have 0, 1, 1, 1, 0, 1. And then we have 1, 1, 1. Next, we can do it for XOR. So XOR would basically be for XOR we have A, B, Y. So that's going to translate to 0, 0, 0. 0, 1, 1, 1, 0, 1, 1, 1, 1. This is what it's going to be. And then for not, right? So this right here would be 0 actually. Then we have the not truth table. So that will be basically A and B. So we have 0, 1, and 1, 0. So these are the truth tables for the different gates. And true if both inputs are true, as can be seen here. Or is basically true if any input is 1. And not inverts as so. Let's move on to the next topic, which is called universal gates. So now we have universal gates. So this has two types. So one is we have firstly the NOR gate, right? So you have the NOR gate, and then we have the NAND gate. So you have NOR and NAND. NAND and NOR can build all of the gates. In fact, most processors use NAND gates internally. Why did the digital signal go to the music festival? To experience the beats. What do you call a logic circuit that's always precise or finely tuned design? Why did the sequential circuit go to the puzzle party? To solve some timing puzzles. What did the decoder say when it decoded a message? I've got a message. Why did the digital system go to the science fair? To showcase its logic. What do you call a logic gate that's always logical? A gate with a plan. Why did the multiplexer go to the networking event? To connect with others. What did the logic analyzer say when it solved a complex problem? I've cracked the code. Why did the binary code go to the therapy? It had a lot of zeros and ones to work with. What did the logic gate say when it was feeling confused? I'm getting mixed signals. So combinational circuits consist of two or more gates. So for example, we have the half adder circuit. Let's take for that for example. So we have half adder. So how this works is basically we have a black box here, which is the half adder circuit. We have two inputs. We have A, we have B. Then we have a sum as the output. And then we have the sorry, carry out. So now this can be represented as so. We have basically an XOR gate, which is used to basically sum two numbers, A and B. So let's say A and B is 1 and 2 here, right? This is 4. This is going to be sum. And then you have an AND gate here, right? So this AND gate has two things. So the first one shifts over here, second shifts over here. So we have 1 and 2 again over here and 3 over here. And then we have a carry out. So this is how a simple half adder looks like, which is basically a combination of it's a combination of XOR and AND. Combinational circuits give output instantly for inputs. Example, adders, multipliers, multiplexers, decoders, etc.
Why did the flip-flop go to the party? Because it was a binary bash and was ready to toggle. Why did the logic gate go to the bar? Because it heard the drinks were on and off. What did the digital signal say to the analog signal? You're always so wishy-washy. Why did the programmer quit his job? Because he didn't get a raise. What do you call a group of logic gates playing instruments? A circuit band.
So next we have what we call as a sequential circuit. So an example of a sequential circuit is an SR flip-flop, right? So the way this works is you have so basically
Why did the flip-flop go to therapy? Because it was struggling to stay in one state. Digital logic is the backbone of modern electronics, enabling us to process information with precision and speed.
so basically you have two input NOR gates, right? And that's connected again to these elements. So we have this over here.
Logic gates are the building blocks of digital circuits, allowing us to create complex systems from simple components. Sequential logic circuits are used in a wide range of applications, from simple counters to complex digital systems. Combinational logic circuits are used to perform specific tasks, such as encoding and decoding signals.
So this is how a simple SR flip-flop looks like. Sequential circuits store memory, flip-flops, registers, counters, CPU memory.
Digital systems are used in a wide range of fields, including telecommunications, computing, and medicine. Boolean algebra is a fundamental concept in digital logic,
So to recap and close,
allowing us to analyze and design digital circuits. Karnaug's maps are a useful tool for simplifying digital circuits and reducing complexity. Flip-flops are a type of sequential logic circuit used to store and retrieve data. Multiplexers and demultiplexers are used to manage data transmission and reception in digital systems. So now we have come to the end of the lecture, and I would like to recap and close now.
digital logic builds from gates, combinational, sequential systems. This is the foundation of computer hardware.